Hi there and welcome to Olagold Academy. Now on the board, we are considering a topic which is motion in physics. Now, what is motion? It is the change in the position of a body or an object with respect to time. Motion is simply the change in position of a body of an object with respect to time. Or you can say that motion is simply the movement of a body. So if a body moves from one point to another, what happened? There is a change in position with respect to time, because as I move from here to the other point, there is time being counted. The time is being counted in seconds. Right. So we can say that motion is a change in position of a body, or is a change in position of an object with respect to time. Or we can say that motion is simply the movement of a body. Now we have types of motion. We have the linear motion. We have linear motion. We have the oscillatory motion. We have the oscillatory motion. We have the circulatory motion. Circulatory motion. We have the rotational motion. Rotational motion. And also have the random motion. So we have this. So linear motion is simply the movement of a body on a straight path, like forward direction of a body. That is linear motion. Forward movement of a body. That is linear motion. This linear motion can be into two types. So linear motion can be into two types. We have the rectilinear motion. We have the rectilinear motion, and we have the curvilinear motion. Now this rectilinear motion, we can use an example where a train is moving on a straight path, is going on a straight path. That is a rectilinear motion. Now when that train wants to bend by a hill, want to bend by a hill, so what happened there? It has undergone what we refer to as a curvilinear motion. Is still going forward, which qualifies it as linear motion, but at that point it has performed a curvilinear motion. But if it is going on a straight path, we refer it to as a rectilinear motion. So that is that about that. Alright, so we have oscillatory motion. Oscillatory motion is the movement of a body to and fro on a fixed point. The to and fro movement of a body on a fixed point. That is what? Oscillatory motion. An example, we have this jingle over in children playground where they used to swing to and fro. That jingle over swing is an example of an object or a body undergoing oscillatory motion. And we also have the movement of a pendulum bob, the to and fro movement of a pendulum bob, where we have an experiment in physics where we are going to tie a thread to a pendulum bob, and we tie that thread to a retort stand, and we swing the bob, and the bob goes to and fro. It goes to and fro, but the thread rather, we tie a thread to a pendulum bulb, and we now tie the thread to a retort can. So we push that particular pendulum bulb, and pendulum bulb goes to and fro. That is what we refer to as an oscillatory motion. The to and fro movement of the body, but is being fixed at a particular point. That is oscillatory motion. Now we have circulatory motion. Circulatory motion is the movement of the body in a circular path. In a circular path, the body is going round, let me say round a path. That is circulatory motion. Round a path is circulatory motion. For instance, if we have, let me say, if you have a bath or a container and you decide to just push a ball, and maybe say you swing the ball inside the container and the ball is going around in the container, that is what we refer to as a circulatory motion. Alright, we have, next one we have rotational motion. This one is also somehow similar to circulatory motion, but the difference is that for rotational motion, it goes in circular paths but on a fixed point. So an example is the rolling of a fan blade, but it's on a fixed path. So it's on a fixed position rather, on a fixed position. On a fixed position. The rolling of the blade of the particular fan at a fixed point, that is a rotational motion. And that one is the wheel of a bicycle or the wheel of a car moving is rotating, but the particular wheel is attached to a particular fixed point. So that is rotational motion. So it's a circular movement of a body, but on a fixed point. On a fixed point. Lastly, we have random motion. Random motion, this one is just the zigzag movement of a body. Like example, we have a butterfly. Butterfly moves in a zigzag direction. It moves in a zigzag direction. That is random motion over there. Alright, without wasting much time, let's go into the next thing we're having for today. Alright, next we are looking into now is the equations of uniformly accelerated motion. The equations of uniformly accelerated motion. So we're looking into this. Alright, we have 4 equations when it comes to uniformly accelerated motion. Uniformly accelerated motion. Number 1, we have V equal to U plus AT. We have this as number 1. Second equation, we have S equal to UT plus half AT squared. Number 3, we have V squared equal to U squared plus 2AS. Number 4, we have S equal to, open bracket, V plus U over 2 multiplied by T. So we have this as our 4 equations of uniformly accelerated motion. Alright, we also have the equations Also have the equations for free fall. When it comes to free fall, also have the equations for free fall also. But before then, let's note some things down. Before we go into the calculation, let's note some things down before we go into the calculation. One thing we should take note of is that when a body starts from rest, the initial velocity is 0. Please take note. When a body starts from rest, the initial velocity is 0. And when a body comes to rest, the final velocity is 0. Are we listening? When a body starts from rest, the initial velocity is 0. And when a body comes to rest, the final velocity is 0. Let's take note of that. Alright, next we are going to define now. Let's look into what we refer to as retardation. Let's look into retardation. So we can see that retardation is a negative acceleration because it is the kind of acceleration that brings a body to rest. It brings a body to rest. So retardation is also another name for deceleration. So it's a kind of acceleration that brings a body to rest. So we call it a negative acceleration. That is for this here. Alright, the next thing we're looking into is free fall. But before then, we are saying that mathematically, we are saying that retardation equal to a negative acceleration. Let's take note. Retardation is a negative acceleration. So we are saying this. Alright. Next we are looking into, let's look into what we refer to as free fall. Now, what is free fall? Free fall is a kind of motion in which gravitational force is the only force acting upon it. I repeat, free fall is a kind of motion in which gravitational force is the only force acting upon it. That is free fall. Or you can say that it is a vertical motion of a body. You can say that it's a what? It's a vertical motion of a body. That is free fall there. Alright, for free fall, we also have the equations But one thing we should also take note of under free fall is that the acceleration for free fall becomes acceleration due to gravity. What did I say? For free fall, the acceleration of that body becomes acceleration due to gravity. That is for free fall here. And let me also add this to it. If we say free fall, example of substances that undergoes free fall, let me say, for instance, if stone falls from a height, if stone falls from a height, it comes down. That's an example of a free fall. But remember, there's also a resistance. Pulling the stone up. Air resistance is also pulling the stone up. But because But because the air resistance is very small, we neglect it. So we can say that air resistance is negligible for stone falling down. Another example is that if mistakenly a phone falls from someone's hand, that is another example of free fall because air resistance is negligible, it's very small. So we don't consider the air resistance. But another example is when we have, let me say, a paper dropping from a building. So what happened there? We will see that the paper is having a kind of restriction when coming down. So in that case, so we can see that air resistance is pulling the paper up. So we can say that this one is not an example of a free fall. This is not a free fall. Another example is that when a plane is landing, the force acting on the plane is not only gravitational force. There is the engine in the plane that is kind of pulling the plane up for safe landing, and also the plane also has wings that can enable air resistance to be much for on the plane. So in the case of plane, force of gravity is not the only force acting on it, and also for paper, gravitational force is not the only force acting on it. Air resistance is also a force acting on it. So it is not only force of gravity that is acting on it. So we can say that it is not an example of free fall. And for aeroplane landing, the force acting on it is not only gravitational force. So we can say that it is not an example of free fall. Alright, that being explained, we have the equations for free fall. We have the equations for free fall, and don't forget, I said the acceleration becomes acceleration due to gravity. And another thing is that the distance becomes height, since it is a vertical motion. The distance becomes height. Becomes what? There becomes height, since it is a vertical motion. Alright. That being said, now one more thing before I continue on writing the equation. One other thing is that if the object goes up, like if you throw an object up, it is going against gravity, so it is negative. But if an object is coming down, it is under gravity, so it is negative. Take note. Alright, for free fall, we have, let me note this down. A becomes G, acceleration becomes acceleration due to gravity, distance becomes height. Let's note this. Alright, so for the first equation of motion, so we are going to have our V equal to U plus GC. We have this. Alright, sorry, plus or minus GT. Number 2, we have S, so we are going to have H equal to UT plus or minus half GT squared. Number 3, we have V squared equal to U squared plus 2 GH. So we have this. And lastly for this, we're going to have H equals to V plus C over T. We have this. Alright, with that being said, if you are confused about how we derive these equations, I've done a video on the derivation of linear equation, and I made it to be very, very simple. So you can do what to check out the video. Is on my playlist, is on my YouTube channel, so you can check it out. And don't forget to hit the like button and drop a comment on that video. Alright, let's move on. So I think that is all that we are going to consider for this. The next thing is going to the calculation. The next thing is going to the calculation. Alright, let me say this before we go into the calculation. This positive here will be used when the question says that the body falls from a height. Negative will be used if the question says that the body is thrown upwards. Remember, if it is going up, it is against gravity. If it's coming down, it's under gravity. If it is under gravity, it is positive. If it is against gravity, it's negative. So positive is used when the question says that the object is falling down. Negative is used when the question says that the object is being thrown upwards. Alright, let's have these equations on one side before we go into the calculation. Alright, question 1 now. Question 1 says that how far will a body move in 4 seconds if uniformly accelerated from rest at the rate of 2 meters per second squared? Alright, let's have to solve that. Solution. The question says that how far will a body move? How far means the distance. That is question mark over there. In 4 seconds, time is 4 seconds there. If uniformly accelerated from rest meaning remember what I told you, that if a body begins from rest, the initial velocity is 0. So we have initial velocity is 0 meter per second. If uniformly accelerated from rest at the rate of 2 meter per second squared. So acceleration is given as 2 meter per second squared. Alright, with these given parameters, what formula is best to be used here? If we check carefully, V is not there, so we can't use this first equation. For the second equation, we're looking for distance. This U is present, T is present, A is present, T is present. We check for number 3, this is not given. So the best equation to make use of is equation 2. So we have distance equal to, and remember, we use S for distance because it's derived from a Latin word. Is it Latin or Greek? Which is spatium. And spatium means distance. So from distance, which is spatium, we use S to denote distance. So we use S for distance instead of D. So we get S from spatium, which means gap or distance. Alright, so S equals to UT plus half AT squared. So we have this. So our distance equal to Initial velocity is 0, so we have 0. Time is 4 seconds, so we have 4. Plus half. Acceleration is 2, so we have 2. Time is 4 seconds, so we have 4 squared. We have 4 squared. Alright, from here, 2 can cancel out 2. So we have distance to be equal to 0 times 4 gives us 0. Plus, we have 1 times 1. 4 squared is 4 times 4, so we have 16. So 1 times 1 times 16 gives us 16. So the distance equal to 16. Remember, distance is in meters. So we have meter as our final answer for the first question. Right, let's go into the second question now. Second question says that a body accelerates uniformly from rest at 2 meters per second square. Full stop. Calculate its velocity after traveling 9 meters. Alright, let's solve that. Given, we are having, from the question, we are having a body accelerates uniformly from rest. So initial velocity becomes 0 meters per second. From rest at 2 meters per second square. So acceleration equal to 2 meters per second square. Alright, the question says that calculate its velocity after traveling 9 meters. So they're asking us to calculate what there, the final velocity. So V equal to question mark, and our distance, which is S, equal to 9 meters. 9 meters. So we have this. Alright, from here now, what formula is best to be used here? We check carefully. If we check carefully, you can see that equation 3 is the best formula to make use of here. V is present, U is present, A is present, and S is present. So we have V squared equal to U squared plus 2AS. So we have this. So V squared equal to our U, which is initial velocity, is 0. So we have 0 squared plus 2 multiplied by acceleration here is 2. So we have 2 multiplied by distance is 9 meters. So we have 9 here. Alright, from here, V squared equal to 0 squared is 0 plus 2 times 2 times 9 give us what? 2 times 2 is 4. 4 times 9 is 36. So we have 36. This becomes V squared. 0 plus 36 gives us 36. Now we are looking for V, not V squared. So what do? We find the square root, or we find the second root of both sides. So we have this and we have this. So V squared, the square root of V squared is V. So we have this. And the square root of 36 is 6. Remember, we're looking for velocity. So the unit is meter per second. So we have this as our final answer. That's for number 2. Alright, question 3 says that an orange fruit drops to the ground from the top of a tree 45 meters tall. How long does it take to reach the ground? Alright, that is the question there. Now let's go to the calculation. Number 3. Alright, the question says that an orange fruit drops to the ground from the top of a tree. Remember, the orange fruit is at rest on the tree, so we can say that the initial velocity is 0 meter per second. So we have 0 meter per second as the initial velocity. It says an orange fruit drops to the ground from the top of a tree, 45 meter tall. So the height is 45 meters. So you have that. How long does it take to reach the ground? We're looking for C there. How long does it take to reach the ground? We are given G to be equal to 10 meter per second square. So we have this. Now, this question here, if we check it carefully, what formula can be best used for this? And remember, this question is another 3-4. The question says that an orange fruit drops to the ground. So it's another 3-4. Alright, what formula is the best to make use of here? As you can see, we're looking for time. Let's take note, we're looking for time. So there's no how we can get time. So what we are going to do in this question is to first of all get our final velocity. If we get the final velocity, we can now apply this formula here to get our time. Alright, so let's get the final velocity first. So V equal to question mark. So we're still coming back here. So we're going to make use of this formula here. From the question, the orange drops to the ground, so it is positive. So we have V squared equal to U squared plus 2GH. So we have this here. So V squared equal to U is what? 0. So we have 0 squared plus 2. G is 10. H is 45. So we have this. So V squared equal to 0 squared is 0 plus 2 times 10 is 20. 20 times 45 is 900. 2 times 10, 20. 20 times 45 is 900. So we have 900. So we have V squared equal to 0 plus 900. We have 900. We are looking for V, not V squared. So we look for the square root or the second root of both sides. So we have this. So V equal to 30. 30 what? Meter per second. So we have this. Right here. Now remember, we're looking for time because the question says that how long does it take to reach the ground? So we're going to bring out this formula here to get our time. Remember, we have now gotten the final velocity. The initial velocity is already present. Acceleration due to gravity is already there. So we're going to have our, let me use this side here. So we have V equal to U plus GC. So we have this. So our V is 30, so we have 30 equal to U is 0, we have 0 more 10. U is 0, so we have 0 plus our G is 10, we have 10. We have 10. Time is, okay, we're looking for time. We're looking for time. So from here we have 30 equal to 0 plus 10 times t give us 10t. So we have this, we have 10t. Alright, 10t plus 0, we have 30 equal to 10t. We have this. Our next task is to divide both sides by 10. So we have over 10 over 10. 10 cancel out 10. So C, so we have 3 equal to C. So we have this. And this implies that C equal to 3. Time is measured in seconds. So we have 3 seconds as our final answer. So this is how we approach questions like this. Alright, I'll be doing more calculations on this topic here on my YouTube channel. So if you find this video helpful, do well to hit the like button, subscribe if you're not a subscriber, share and drop a comment, and do well to like this video. This is Olagood Academy. Thanks for watching.